Welcome to the workshop. Today we want to take a look at section 2 of the appendix, logical equivalence. Now, in this section, we're primarily going to look at truth tables and try to get an understanding of kind of what we're looking at with our connectives, and then as well try to look at, of course, the logical equivalence, but that will primarily be just in our last example. And that will bring us into some ideas of writing proofs, but we'll continue to use this idea in the next section as well, bring ourselves back to these ideas as needed there. So for now, just the basic ideas of the truth tables, some better examples than some larger examples than the previous section, and then again, logical equivalence. So let's take a look at our lecture notes. All right, so we already mentioned previously that a compound statement is formed by one or more statements called component statements. So P and Q, P or Q, not P, P implies Q. All of these are compound statements with component statements P and Q. Of course, not Q is a compound statement, but it only has the, not Q is a compound statement, but it only has component statement Q, so one or more. Okay, and then the truth table displays all possible combinations of truth values for the component statements, and then gives the associated truth values for the compound statements. So we already took a look at most of these first ones in the previous section, but I'd like to revisit them again. So if I want to talk about the compound statement P and Q, I of course need to know the truth values of P and Q. So I want to look at all possible combinations of these two specifically. And once I have that, then I can look at the truth values of P and Q, the compound statement. So again, all combinations of P and Q. Well, we could have P is true while Q is true, P is true while Q is false, P is false while Q is true, P is false while Q is false. Okay, pattern recognition here, true, true, false, false, true, false, true, false. Okay, so we're just running through a pattern, so that will be pretty quick every time. But now P and Q, the conjunction of P and Q is true when both of the component statements are true. So it's true in the first case and false otherwise, because this is the only case in which both of them are true. So this is the truth table for P and Q. Now, these are small examples, and so it's hard to observe right now, but we'll see shortly that when we're constructing truth tables, each column should only be the application of one connective at a time. So in this case, I only have one connective to apply, but we want to, again, make sure that we're only, for each column, is only applying one connective to previous columns. In this case, that's the only way it can happen. So we'll take a look at some more examples a little bit later that have more. So P or Q, that would be disjunction here. So again, we want the values of P and the truth value of P and the truth value of Q, all possible combinations, and then use that to determine the truth value of P or Q for each of those combinations. So true, true, false, false, true, false, true, false. That's all possible combinations. And then this is true whenever at least one of the component statements is true. So one of them is true, one of them is true, one of them is true, neither of them are true. And really, I should say at least one, at least one, at least one, because of course there's two in this case. All right, true and true. Sorry here. Neither of them are true, so it is false. There we go. That looks pretty good. All right. The implication, again, we'll need P, we'll need Q, and then P implies Q. Excellent. All possible combinations, true, true, false, false, true, false, true, false. We have all combinations. Now, the implication P implies Q, or the conditional statement P implies Q, is true all the time except for when P is true and Q is false. When P is true and Q is false, we have that it's false. Otherwise, it's true. Easy enough. All right, so now the interesting one. This is the one that we saved for this section, and this one does require a little bit more work. So we need a little bit more room here. So P implies Q is true when both, P if and only if Q is true when P implies Q is true and when Q implies P is true. But that's the same thing as saying, right, this is the same thing as P implies Q and Q implies P. So we want to construct the truth table for this. But that means we have to find the truth values for this, and we have to find the truth values for this, and then we can combine them to get the disjunction. Sorry, the conjunction here. Okay, so of course we need P and Q. P, Q. We'll need P implies Q. We'll need Q implies P. And then we'll need their conjunction. P implies Q and Q implies P. So there's several more columns to this example. But in each case, right, each column is either a component statement or it is a compound statement that can be found by one connective of the previous columns. So this is the connective of implication, or a conditional statement joining P and Q. This is the conditional statement joining Q and P. This is the conjunction of this column and that column, right? So I'm only ever combining two columns to create a new one. I don't want to consider multiple columns at once. It becomes very confusing, okay, if I tried to consider too many things at once. So I should just be taking two things and joining them using one connective to create one column. So component, component, we start with those. And with two component statements, it's the same setup every time. P implies Q. We actually already found that up here, so it's true here, false, true, true. Now Q implies P is going to look a little bit different. Now we're working from this one to that one. So true, true, that's good to go. False, that's good to go, because anytime the premise is false, the conditional is true. So we know it's true here, and we know it's true here, and then true, false. That's the only case where it's actually false. Excellent. So we have P implies Q and Q implies P. From there, we are looking at the conjunction of these two columns. So when are both of these columns true? Well, they're both true here, and they're both true here, but they're not both true here. So false and false. And these are the truth values for P if and only if Q. Excellent. So that's a good example where we actually have a bit more going on, requiring several columns. So this is fantastic. All right. But that's all that I wanted to take a look at for now. Just a nice reminder of the truth tables that we've seen and one new one. In our next video, we'll take a look at a few more, or two more rather, truth tables, just to get a little bit of additional exposure to the truth tables. So I'll see you guys back in the workshop very shortly.